locally. All right, welcome everybody, and thank you especially for Sylvester for agreeing to kind of be my rubber duck. So I have somebody to explain it to because I really don't like uh, talking to a camera by myself. So what we're going to do today is go through the existing infrastructure that we have for creating Helm charts, and we're going to go through this initially from the point of view of a user using our service or using our platform. And then I'll dive a little bit into what the original plan was to get this deployed onto the Kubernetes cluster and how some of that might still be valuable for the current plans and what things we may kind of consider or throw away. So let's start at the beginning. This is the GitLab CI YAML file of our example service. So that kind of simulates a user that is using Runway. In order to generate a Helm chart for their service, they need to include another CI task. And this is split out primarily for the reason that users can opt into the Helm chart generation. So that AI Gateway already kind of generates their own Helm chart, and I didn't want to conflict with this. This could in the future be kind of streamlined and imported into the Runway YAML file or something like that. But for the time being, this is a little bit separate. So you import this Helm chart, you provide some information, most importantly, the Runway service ID. This is similar to what we're providing for other imports. This is a little bit clunky that you kind of need to report the Runway version again. Something that we can solve. We've solved this for the Runway YAML file. It's just for prototype. This is good enough. And then what may be a little bit confusing is the app version, which is the CI commit short SHA, I think. This expands to the tag name if there's a tag for the commit, and otherwise it's like an abbreviated SHA version. That has a specific reason because Helm charts enforce that they are using semantic versioning. So at the end of the day, you have to arrive at something that is a semantic version. And we're piggybacking, or in order to do this, we need to know kind of the concrete commit that you're trying to create a version for. And how that is used, I think we'll see in a few minutes. So what this does is basically it's configuring which version of the repository, which version of the CI definition this is importing. The kind of the template that is used to generate the Helm chart is stored in the Runway control repository, and users can, in principle, override the version that they're using if they want to pin to a specific Helm chart. But again, this is useful for testing, not so much as this is a feature that we built in order to kind of get ahead of the curve or get ahead of the anticipate future features that people might have. So this is primarily for testing. So this is what users would add into their CI file. Relatively straightforward, very similar to what we're doing for Runway for other like services and jobs. I want to skip ahead to this. So this is the example service container registry. And what the Helm chart import is doing, it is creating a new kind of path inside the container registry chart / and then the Runway service ID. And inside there, you have a Helm chart basically for each version that you build. So 1.9.15, for example, would be probably the latest version. Now, not every commit to a repository is creating a new version. Like if you have the chore prefix, semantic release doesn't cut a new version. But we're still building a new Helm chart at that point. And what we're using here is the format that is used by git describe. So it's using the latest tag, so 1.9.15. Then it's the next number is the distance to the last tag. So there have been 2 commits since the last tag. Then there's a G prefix that I do not know what it stands for. Maybe git, maybe it's just the first non-hexadecimal character, I don't know. And then this is the commit ID or the abbreviated commit ID. So by using the commit IDs inside the version, this is more or less guaranteed to be unique. And by adding the number of commits since the last version, this kind of follows the semantic versioning rules. And so you can see this kind of counts up in steps of 2. I think because there's a commit and then there's a merge commit when we're using merge requests. So this is kind of stepping up by 2. So there you can see that presumably there have been like 8 merge requests since the last version has been tagged, since the last feature or bug fix has been done. So this is roughly what users would get. We can certainly tweak this to make sure that the latest version that is actually built from a tag gets like a stable label or something like that, that it's easier to kind of import. So this is what users would see. Now, what's actually inside the Helm? Or any questions up to this point, Sylvester?
No, not really. I thought I was involved in the initial review when you were building this out, so I'm kind of familiar with this part.
Okay, awesome. So the implementation is very prototypey at this point. So this is not an example of good design. So just a heads up, right? So you can tell there's a lot of shell scripting going on inside the CI definition. This would eventually be wrapped into the runway control binary, but for the time being, this is relatively easy to kind of work with. So some of this is inside runway control, and I'm trying to locate where we're actually calling out this, just setting up the environment. So that is basically creating a .env artifact with a bunch of variables that kind of control the behavior of the job. And then the actual job creation happens here in create Helm chart, which extends this one here. So as you can see, there's runway control, Helm create, and then you pass in a version and an app version and a destination, and that's kind of already like wrapping the Helm chart creation. I think the code in there is not super interesting. What is more interesting is actually what the Helm charts do. So at this point, when the service owners create a Helm chart for their service, we're talking about the runway base chart, which is the one that is the basis for the service chart. The idea is that this base chart is provider agnostic, so it does not use any GKE features or Amazon features or I don't know what have you engineered. So it's vanilla Kubernetes, and it only has things that are basically applicable to the service, but not like a concrete customer or concrete user. The values that go in here, the values file is empty, and what is being injected here is the runway GKE service YAML file. So basically the runway YAML file that we have for our other services. You can see you can like add labels here, and this is important because it tells the further process then that this is supposed to get deployed onto GKE, and it pulls in GKE specific stuff. We're going to get to this in a little bit. But the idea is that we have the Runway YAML file inside the service repository, and that is the input for the Helm chart. And then the Helm chart is written in a way that it kind of dissects the Runway YAML file and uses this as an input to kind of create the appropriate resources that are needed. And so this is the values file here is empty, and it's meant to basically document the available keys, similar to the schema file. So schema file is probably a better approach to do it, but you do have to have this file. The chart is, it's adding a description and a name for the chart. The version and app version are then overwritten by the values provided by the user or by the CI system. And then in here are the resources that are being created. I created one file per resource so that it's relatively easy to navigate and to see. So there's the service account file does what the file name says. It's creating a service account. The main file is maybe interesting because it kind of pulls everything together. So it's creating the namespace, and then for each service definition, well, this is a discussion to be had. Do we want to have multiple services in one Runway YAML file, or is one service per YAML file per deployment enough? And then deployment, horizontal pod autoscaler, disruption budget, service account, vertical scaler. And so this is kind of the very basic shape of the service. And this, at the end, would create a like if we take this very generic set of templates, we inject the GKE service YAML file as a values YAML file, and what we end up with is a Helm chart that we can distribute to users.
Sorry, just to clarify, just to check. Like, so if like charts are built out of Runway base, technically could it be deployed to a local like a kind cluster on your local PC, just with this set of charts?
Yeah, it
That's the
could.
idea, right?
It could. You'd be missing a few things that you need in order to actually communicate
Ah,
with the
okay.
process. For instance, there's no ingress or gateway that
Ah,
is being
okay.
defined yet. Because in order to define an ingress, you kind of need to define a host name that the ingress binds to. And that is not something that we can kind of dictate generically for the service as a whole.
Yes.
This is something that's specific to the deployment. And so that is something that would be in the deployment chart that we'll talk about next.
Ah, okay.
So as I said, this is the basis for the service, a basic Helm chart. In order to deploy it, we need to add a few more things. And the things that we need to add are either specific to GitLab, or they're specific to kind of the provider, GKE in this case. And that's why they've been factored out. So in order for us to deploy the service on our cluster, we need to do a next step. And this is where the deployment chart comes in. This is it. The deployment chart is ephemeral, meaning inside a CI pipeline, we do create a deployment chart, and then we evaluate the deployment chart. But the deployment chart itself is never uploaded to like a container registry. What we do upload is the evaluated files that are being produced by the deployment chart. Yeah, I'll demonstrate this in just a minute. So basically, you can, like conceptually, you can think of the Runway GKE chart as inheriting from the base chart. So it has everything that the base chart has, and then it adds some things on top. So in this case, it adds a few GKE specific things, like service export is used for like inter-cluster communication for kind of a regional deployment or multi-region deployments. Gateway and HTTP route are kind of the GKE specific ingress resources that are being used and so on. And in here, it's again using kind of information from the GKE service YAML file, the Runway YAML file that we've seen. So for example, the service has a protocol field, and this can be either HTTP or gRPC. And if it's gRPC, then we kind of configure gRPC health checking and otherwise HTTP health checking. When or after we create these, so we create this deployment Helm chart in the deployment pipeline, and we create these Kubernetes resource files, and then they are being uploaded to the deployment project. So that we have to yada 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 runway/deployment/example service random suffix. And here inside the container registry, we have it's using a prefix deploy, so as to not to clash with potentially other packages that we might want to create in the future. And it creates two tags, one for staging, one for production. At the moment, it creates both tags simultaneously. I think for a real production use, we'd probably want to create a new tag using the version every time, and then have staging and production as like floating tags that we adapt over time in order to deploy it. But for the time being, this is kind of fixed. What I wanted to do very quickly is inspect what is happening inside here. So I have a shell here. Is that readable or is it too small?
It's fine. It's quite zoomed in, so it's all right.
Okay, yeah, I made it the traditional 80 by 25 to be relatively readable. So the entire setup is kind of assuming that we're using Flux to kind of pull these resource definitions from an OCI repository and then deploying it to the cluster. And so in order to inspect it, you would use the Flux command line. So it's Flux pull artifact. This is kind of the command that you can use to pull it. I'll very quickly copy the path from the container registry. So you can see registry.gitlab.com/gitlab.com GitLab infra platform runway deployments example service/deploy call production. And what we still need here, because Flux is a little bit picky about this, we need an OCI prefix, and then we need to say output. And we need to tell it where to store it. So it downloaded the version that is tagged with production, and it's written it to out. So if we look at out, you can see that there's a single resources.yaml file that got downloaded on the OCI registry. And if we take a look at it, you can see that it contains the fully evaluated resources that are to be deployed by Kubernetes. So at this point, all the processing, all the logic has happened. There's very little logic happening inside the cluster, and it's fairly easy to kind of inspect what we expect the cluster to kind of contain. So we look at the service, for example. You can see the labels that we defined inside the GKE service YAML file should show up here again, for example. Okay. What else is there to show? The implementation inside Runway control is all in the command Helm subdirectory. And yeah, there's like create list push. So the create command, what does it actually do? We're gonna see. So essentially it's creating a temporary directory. It's calling Helm package, and then Helm lint in order to make sure that things are all right. And then push is uploading things to a remote repository. So in the OCI repository inside inside the deployment project. It might be worthwhile to maybe take a quick look at the CI tasks for GKE. So one runway control CI tasks deployment project GKE YAML is where we generate the deployment chart, evaluate it, and upload it to the container registry. And so that happens here. We create the deployment Helm chart. This is also very prototypey, so this is probably something that we wanted to migrate to Runway control. But we have this kind of template here of the chart YAML. It injects the chart name and the version and the app version, and then it basically says we need the Runway GKE file and the service YAML file. It's kind of putting it together. This is kind of how the inheritance, so to speak, is implemented. Then it runs Helm dependency update in order to grab the base chart, the service specific chart in the GKE chart. It runs lint again just to kind of be sure that there are no problems here. Yeah, this is basically a debugging output of everything that we have inside the repository. And then it's packaging everything into, or it's, I think Helm package actually evaluates. No, it does not evaluate. It's creating the Helm chart kind of in a temporary directory and then uploading it as an artifact. So the deployment Helm chart is created as a deployment artifact so that if there is a problem within 1 week after creating like a new release, you have the option of going to the CI pipeline, downloading the Helm chart and inspecting what it created and what it kind of evaluated. And then here in upload resource manifests, we need this first. Build resource manifests, downloads the deployment Helm chart, downloads upstream artifacts. So this is primarily the GKE service YAML and the service Helm chart is contained inside the deployment Helm chart at this point. And so what we do here is we run Helm template with the values file, that GKE service YAML file from the service repository. This is evaluating all of the templates and writing the raw resource manifests into a file, which we upload as an artifact again. And so you have the option, again, within 1 week after creating a new release to look at the Helm chart, but also the evaluated resource manifest to find out what are we actually pushing into the cluster. And then what this does is it's taking the resource manifests we created and uploading it to the OCI repository, which is what I just showed you how to download and inspect. And again, there's a little bit of fiddling going on with the exact revision numbers and version numbers. Like all of these tools are oddly specific about the versioning that you're using. Right, Sylvester. You have the opportunity to ask questions representing everybody on the team. What do people want to know at this point?
Ah, okay, so at this point, I'll probably be thinking of like the deployment. Right now, I'm presuming we're just pushing it to Flux, the OCI repository, yeah, repository, and the Flux controllers would handle it in a pool basis, right?
Correct.
Whereas differently, right now we would just do a Terraform apply, and it's all like push based. Uh, yeah. So
Right. Yes.
that's the model we have in sort of in place. Yeah. Okay.
Correct. So the Flux model is that Flux is essentially polling a OCI repository. You
Okay.
can configure how often it does so. It's not the most costly operation, so it's usually done somewhere between every 1 minute and every 5 minutes. I think going significantly under 1 minute, like if you were polling every 10 seconds, I think that would create unnecessary load. I think there's a new kind of TLS connection established every single time. And yeah, I think it would make kind of operators unhappy eventually, um, particularly as we onboard more services.
Yeah.
Um, what you can do in order to kind of cut down on the time it takes for Flux to pick up new versions is you can use the Kubernetes GitLab agent for Kubernetes. I think it's called KAS, KAS. Well, the acronym doesn't make any sense to me.
Yeah.
Um, in order to uh, push a notification into the cluster so that the GitLab instance can, like, there's a mechanism that allows the GitLab instance to inform the cluster about a new container image being available, and then the Flux controller can pick that up like immediately. We haven't set that up yet, but it's something that exists.
Okay. Yeah. Then I guess the other thing would be like the canary. We will have to depend on the Flux or whatever deployment platform we use to do the traffic splitting. Right? Because right now we can't do it manually right now. Whenever we perform Terraform apply, we set the traffic percentages, sort of do a gradual cut over. Whereas in this case, if you push the package, you leave the the deployment strategy sort of to
Mhm.
the platform you're using. But right now it's
Right,
it's it's Flux, and depending on what we go in the future, it could be the runway controller, I guess.
right. Yeah, there's a deployment controller in Kubernetes that is kind of doing it similarly to like Cloud Run would do a deployment. Um, as far as I know, this is kind of the way to go, that you
Yeah.
have a controller inside the cluster and you tell it to slowly switch over traffic from one instance to another or something like that, or from one version to another. Um, yeah, I think if we were to control this behavior from within a CI pipeline, that would be a little bit like backseat driving. So
Yeah.
I think the controllers inside the cluster are better positioned to kind of do this sort of work.
Yeah. Yeah, I agree. It's, um, I'm trying
Well,
to think of what else would uh members like anyone new to this would want to ask. Uh, uh
so
what about rollbacks though? Like right now would a rollback just be like right now the way you do a rollback is we sort of the easiest way to do it is just push a new commit on the service project. Then you do the whole building process, and a new tag comes out. That tag becomes latest, and because it's latest, we deploy it.
Yeah.
There's a cleaner revert like rollback which is built into the pipeline, but then we're just chucking logic into the CI the manual CI pipelines. That whereas for this uh the rollback process will be done by the I guess the operator.
So I think a good rollback process might be to go into the deployment project and like if we have version 1, 2, 3, 4, 5 down here is as
Yeah.
individual tags, then we can kind of point this production label to like a
Okay.
previous version, and then we can say, okay, we version 5 is broken or doesn't perform as well as we thought it would. Let's let production point back to version 4, which kind of is a little
Okay.
bit more established, and we know that it works.
Yeah, fair.
And then ideally, like rollbacks you want to do as fast as you can, you'd probably uh, maybe have a CI. Maybe we'd want to have a CI process for that that kind of does the label switching and then kind of
Yeah.
tells Kubernetes that this is a rollback and that the rollout process should be expedited. So there's no canarying and just push it as fast as you can to all of the nodes, something like that.
Yeah.
Um,
Sounds good.
at the end of the day, like to connect it to Brennan's suggestion with a runway controller or runway operator, I think a runway operator could contain most of that kind of deployment logic, and that would probably be a much better place to have it compared to like CI pipelines and labels in OCI repositories and stuff like that.
Yeah, fair enough. But I guess the rolling back would be like if we have many services, the uh the point I'm trying to make is like if the rolling back logic is in one operator and the operator is like there's a bug and a bug in it, then you kind of affect everybody. Whereas uh right now right now we lean to the GitLab CI, so I guess if it breaks down, everyone is affected still. So okay, maybe it's not really that much of a concern. Yeah, but I think the point is that if we chuck too much logic into the operator, then we have to be very careful about how we do it, because it's gonna affect everything. Depending on how we want to structure it. But yeah, right now in my head, I'm just thinking
Yeah,
of a one
that's
overall operator.
yeah. I think this is generally a risk with automating deployments is that if if you introduce a bug in the process of the deployments, you run the risk of kind of severely hurting your deployments in an automated manner, as in very quickly and very widespread. So yes, for sure, we need to be very careful and cautious about the entire process and build in as many kind of safeguards as we deem
Yeah.
necessary.
Yeah, but I guess that's separate for now. Like it's a
Yeah.
separate issue from the chart building process. So yeah.
Yeah. So what I like about this approach is that the our users have maintainer rights on
Yeah.
their deployment projects. And so the AI gateway team can go in and kind of fiddle with these labels if they want to roll back to a specific version. I think we have an obligation to kind of assist them with appropriate tooling to do so, but they can self-service this at the end of the day, and that is, I think, a great position to be in. What I haven't fully grasped yet, or haven't fully wrapped my head around yet, is how would this translate to how a self-managed customer would manage this? Like the creating the deployment Helm chart and pushing it into the cluster is a non-trivial task. Um, I don't think it is reasonable to assume that all of our customers know how to do this or have the bandwidth to implement it.
Yeah, that's true. Like right now, if someone wants to roll back and they're using the cloud native charts, they will have to sort of update the version to a previous version and do a apply and like apply that change to the cluster. So
Yeah.
it won't be like us where we can just because technically we control this repository. So
Yeah.
yeah, unless they have a similar setup to us, but it might not be. But then the problem comes with dedicated. I think I thought about it like uh because self-managed users operate and use their own project, whereas dedicated operate for the users, but it's a bit weird if dedicated, like the team managing dedicated were to create like this kind of repositories in the user's GitLab instance. So it's like, yeah,
Yeah. So one idea that I picked out from our team discussions is that we could bundle the inventory with the runway controller so that the runway controller comes with AI gateway at a specific version and the other services that we eventually onboard at very specific versions. And in order to upgrade the AI controller, in order to update AI gateway to a new version, you would need to upgrade to a new version of the runway controller.
oh, okay,
Um, that that would make it easier to kind of distribute versions to customers and would give customers control over which version is running on their cluster, and they wouldn't get surprised by new versions. But it would, like, if we were to do the same for GitLab.com, I think we'd position ourselves as gatekeepers to getting new versions deployed. And I don't think that we want to be in that position. I think one of the value propositions of Runway is that uh, service teams can iterate quickly and they can get their code into production without us having to kind of cut a new
yeah,
release of a runway controller. And so
yeah, that's true.
not entirely sure yet how to kind of balance these two interests.
Yeah, that's true. Like right now, we don't really have a version. Like we don't really have a runway controller version. Like we have sort of the runway control like runway CTL version and
Mhm.
the CIMO version, but that one is a
Yeah.
little different. Uh, oh, yeah, that's tricky.
Yeah. Yeah, the runway control version is very important because I think we're bundling all of the Terraform files and
Yeah,
Terraform modules with runway control. And so
yeah,
the entire service shape is basically how does a service look like is encoded in runway control.
yeah, that's true.
The Yeah, there's also bundling between the CI definitions and runway control, but I think the runway control surface has not changed that dramatically, and so this is less of an issue, but it's still good to have.
Yeah, it's okay.
All right, so
Yeah,
I think we covered quite a bit of ground. I don't think there's any value in us continue to ramble here on the recording.
yeah,
So um,
yeah. I can cut it here.
yeah, so this is meant for members of the team to kind of get an idea of how the Helm chart process currently works and what we have implemented. Um, and yeah, what I wanted to say finally is none of this is set in stone. This is all a proof of concept. Everything's up for discussion. If you don't like something or if you see a problem with anything, please do point it out. Let's continue the conversation and come to a conclusion that kind of everybody can support that we can move forward on.
Yeah, sounds good.
Awesome. Now, enjoy this awkward silence while I try to figure out how to stop the recording. I think there's a button. Bye.